Herzlich willkommen.
Welcome to episode 5 of our information series, Basics of Electrostatics. With this information series, we want to share our know-how about electrostatics with you to make electrostatic applications safer.
Correct, Michael. If you remember, we looked at ion wind in the last video. And today we want to take a look at how far such an ion wind actually goes, or rather over what distance ions and electrons can be transferred.
Über was für eine Distanz sich so Ionen übertragen kann oder Elektronen auch.
We don't just shoot away ions at the needle tip, but also electrons. By the way, this is also very important in practical applications. For example, we use electrostatics in painting and powder coating, and there, a needle electrodes is used for charging the powder. And we should always keep in mind that this is not only possible over short distances. But let's take a closer look now. I have brought a glockenspiel for this purpose. By the way, we will show you how the glockenspiel works in detail in the next video. Today it is only there so that you can see, as soon as the glockenspiel is ringing, there is charge on it.
So.
Okay, and as you can hear, the glockenspiel is ringing. And if I go further away, it is still ringing.
Selbst jetzt bimmelt.
Even now it's still ringing, and I would say that we now have a distance of about 1 meter or 3 feet for Americans. This means that I can transfer the load over a distance of 1 meter.
Und das sollte man natürlich immer im Hinterkopf.
And you should always keep in mind that if there are any parts on an electrostatic system that are not grounded properly, for example, they can charge up.
Also ganz übel.
Very impressively, we can show this in this experiment. For example, if I take this cage and put it here, and then spray with the needle towards the cage, then this cage will slowly charge up. This happens because it cannot discharge because it is standing on an insulating PVC plate. Look what happens when I now bring this ground wire closer to the charged cage. Then there has been a spark from the cage to the ground wire, and that can be dangerous, of course. But that's not why we have the cage here today. Michael Faraday discovered at some point that the charge can move freely in a body, and that I can then shield something like that using a Faraday cage. Everyone has already heard of it when we're sitting in the car. The lightning doesn't do anything to us because the body of the car is a Faraday cage and the current is conducted around us. Here we have again the glockenspiel ringing. But if you now put the cage over it, it's still ringing. Why?
I know why.
Then tell me why.
I think there is still a wire missing.
Exactly. We have to ground the cage. For this purpose, I now attach a grounding wire here, which is connected to our entire grounding system. And if I now spray onto it again and try to make it ring, then nothing happens. Even if I get very close to it, I no longer get a field inside. And therefore the glockenspiel no longer start to ring. In the field of electrostatic coating, it is exactly the Faraday cage that causes problems. And that's because when we coat, we don't get the coating material deep enough into this Faraday cage. The cage shields the field lines, and you have to deal with them differently. And that's it for today. I hope it was interesting, and in the next video we will take a closer look at why this glockenspiel is actually ringing. I hope you are looking forward to it as much as I do. And Michael, as always,
if you liked it, then don't forget to subscribe and look at our channel. We will continue to make videos in this series. That's it for today. See you next time.